Hello student, good morning. How are you? I hope you all are happy at home. So, what we did yesterday, what we did or what did we discuss yesterday? We discussed some of the physical properties of the organic compound, such as melting point, boiling point, solubility in a particular solvent. These are some of the important property we have learned, we have discussed yesterday. Today I am going to discuss further point of this chapter. So we are discussing about chapter number first. The name of our chapter first is the fundamentals of organic chemistry. In that we are going to learn electronic displacement. Electronic displacement means how the electrons are present in the organic compound, that we are going to learn today. So, first of all, functional group. What do you mean by the functional group? Organic compound containing many functional groups are there, like alcoholic group, aldehyde group, phenolic group, carbonyl group, or amine groups. These are the halide group. These are the functional group. In short, we can call it as the site of reaction. Site of reaction means what? The functional group, in short, defining as a site of reaction, means in general, whenever any organic molecule react, part of the molecule actually undergoes the chemical change is the functional group. So that is the definition of that functional group. Or I will define the functional group. I am going to give you second definition of the functional group. The atom or group of atom that determine the physical as well as chemical property of the particular family of the organic compound is known as a functional group. Now let us functional group either increases electron availability on the functional group, either increases or decreases the electron availability on the functional group, and therefore the reactions are occur. Let us consider some of the reaction here, then and then you can understood. Let me try to explain this concept in detail. Let's first example ethylene. First one is ethylene reacts with hydrogen bromide. HBr is called as a hydrogen bromide to form ethyl bromide, right? So this is the simplest reaction. Ethylene reacts with hydrogen bromide to form as a ethyl bromide. And here as you know that the structure of ethylene is this one, CH2 double bond CH2. This is the structure of ethylene. This is called as a ethylene, and ethylene containing as a functional group, carbon-carbon double bond is a functional group, and now there is addition of hydrogen bromide, and as we know that hydrogen bromide is like this. And simplest thing you remember here, when the reaction is occur or when the reaction get initiated, if there is a electrophile and nucleophile is present, and as we know that nucleophile or electron rich in species, means they are the searching for the nucleus, means nucleus loving species, that is called as a nucleophile. And electrophile means what? They are the electron deficient in nature. Electron deficient in nature means they are searching for the electron, means they are the electron loving species are there. And therefore when there is a opposite charges are there, then and then a reaction takes place, otherwise there will be a no reaction. Opposite charges are there, then and then electrostatic force of attraction generated and the reaction takes place. Look at here, carbon-carbon double bond, it is a nucleophilic in nature, and this hydrogen bromide is a electrophilic in nature, and this is the reagent, this one is a substrate, or we can call it as a starting material or reactant. And this reactant has a source of electron. Here we can call it as a partial positive charge and partial negative charge on the bromine atom, because bromine atom is a more electronegative than hydrogen atom. Now when this double bond attacking on that hydrogen atom and the bond is breaking heterolytically, and so that both the bonding electron pair concentrate on the bromine atom, and we are going to get here CH2 positive charge over there. When this double bond shifted from here to here, what is going to happen on this carbon atom? There will be a 3 hydrogen atom, and when the species, organic species or the carbon atom carries a positive charge, that species is called as a carbocation. Here carbocation, and that carbocation further it is Br minus. And now look at most of the student, you might get confused how to show as an arrow. Mechanism is a language of organic chemistry. Once you know the mechanism, the use of language, as we know that you can express your thoughts or your feeling in a better way. And similarly in the organic chemistry, if you know the mechanism, you can understood the organic chemistry very easily. Now look at here, negative charge. Here it is flowing, means it is a nucleophilic in nature, it is electrophile in nature. This negative always show the arrow from this side, don't show arrow from this to this, if that is a completely wrong. So always remember negative, just like as water flows from higher level to as a lower level, similarly then, and the resulting compound you are going to get here CS3 CH2 Br here, and this is the ethyl bromide we got here, right? So this is one of the reaction. Now let us look at as another example. Second example, which is, as we know that everybody knows that the benzene is aromatic in nature, and now this benzene reacts with NO2 plus, means nitronium ion, to form nitrobenzene, right? Now most of you may be knowing the structure of benzene, right? Most of you not, you all are knowing the structure of the benzene. This is a cycle and alternative carbon double bonds are there, and that's why it is a structure of benzene. And as we know that this benzene is a nucleophilic in nature, and NO2 plus, and aromatic compound, they have one tendency, or what we can call it as a special characteristic of benzene, is that they always undergoes as a electrophilic substitution reaction, and therefore this negative charge attacking on that nitro group, the product forming will be the very simplest product. I am not going to show here the mechanism, just I am trying to explain how the products are formed, and because we are going to I am going to explain you how the functional group, what do you mean by the functional group. Now here we got the product, the name of this product is a nitrobenzene, very correct one. These nitro groups are there, therefore you can call it is a nitrobenzene, right? This is the structure of nitrobenzene. Now let us look at as another example, that is the third example here I am taking. Let us see here, third example will be this one. Third example, ethyl bromide. Ethyl bromide reacts with aqueous base to form ethyl alcohol, right? This is the simplest reaction I am taking here. Ethyl bromide reacts with aqueous base to form as a ethyl alcohol. As we know that aqueous means whatever bases are there dissolve in a solvent, that's why it is called as a aqueous. Let us look at the structure of ethyl bromide. Just now we have seen this is a CH3, now CH2 and then Br, right? And that will be treated with aqueous base like maybe as a sodium hydroxide. The resulting compound, what is going to happen here? OH minus is a nucleophile approaching to this carbon atom, and Br is a living group, so it depart from that substrate, and we are going to get here CH3, CH2 and OH. This is the main product, don't think about the side product. So here ethyl alcohol we got here, right? Now there is a two carbon atoms are there, right? Look at carefully. In this case functional group is alkyl halide. When bromide attached to those carbon atom, that carbon atom becomes as a electrophilic in nature, and they are more electrophilic in nature than this carbon atom, and therefore nucleophile approaches to this methylene carbon rather than the methyl carbon, because when these Br attached to this, that becomes as a bromine atom is a more electronegative in nature, so it pulls the electron density around it, so it shows as a partial negative charge, and this carbon atom becomes as electrophilic in nature, means having as a partial positive charge, and therefore the resulting compound we are getting as a ethyl alcohol. And that's it. Now let us look at as a fourth example. In the fourth example, suppose we have a compound like as acetaldehyde reacts with hydrogen cyanide to form cyanohydrin derivatives, and that is a speciality or the special characteristic of that hydrogen cyanide. They get reacted with in this case here you might be knowing the structure of acetaldehyde. Look at the structure of acetaldehyde, this one CH3 C double bond OH, then treated with hydrogen cyanide. When that hydrogen cyanide, there is a nucleophilic substitution reaction takes place, and the product form will be this one CH3 then OH CH and Cl. This product is called as a cyanohydrin derivative. Cyanohydrin derivatives, right? Now these are the four simplest example I have taken. Now here, look at here, this carbon atom, this is a carbonyl carbon atom. This carbonyl carbon atom is a electrophilic in nature, and therefore the nucleophile attacking on that carbon atom rather than methyl group, and we are going to get as a product, the resulting product, name of that resulting product is a cyanohydrin derivative. Got it? Now if you observe these four reactions which I have just discussed, what do you see there? There in every reaction there is a changes occur at a particular part of the compound only. Whole part of the molecule is not changed. Only specific part is changing there. Look at here. This is a part changing like this. This methyl, this other part of the molecule remains intact, only at a specific site or specific part only changing, and that's why it is called as a reaction. It is called as a functional group, means site of reaction. Whenever we are adding the reagent, the reaction occurs at the functional group. Means suppose, let us look at as a next point will be the reactivity. We are not discuss it or till, that is a reactivity. So reactivity, what do you mean by again as a reactivity? Even though two different compounds having the same functional group, or containing as a same functional group, they will undergo similar type of the reaction, but the rate of reaction need not be the same. Let us see the example here again. Here the examples are this one. Suppose first one, CH2 double bond CH2, all alkene react with hydrogen bromide gives or produce alkyl bromide, because all the alkene having as a functional group carbon-carbon double bond, and there is a addition reaction takes place, and the resulting compound we are going to get as a alkyl bromide. And therefore when we are adding as a hydrogen bromide here, we are going to get the product CH3, CH2 and Br, right? Ethyl bromide. Now let us look at as a second example. CH3, CH double bond, then CH3, that is a 2-butene, right? This is a 2-butene. Why 2-butene? Because that these two indicate the position of the carbon-carbon double bond. I am adding the same reagent, hydrogen bromide, and the resulting product is obtained here, CH3, CH, Br and CH2, CH3. The product we are getting here, the name of this product 1, 2, 3, 4, and this is a 2-bromo butane. That is a IUPAC name of this compound. Similarly 1, 2, 3 and 4 at 2 position carbon-carbon double bond. The last suffix is ENE, indicate as a carbon-carbon. This is a ethylene treated with. But the rate, if you determine the rate of both the reaction, what do you find? This one react very fast, whereas this one reacts very slow. There is a slow reaction takes place, it is very fast reaction. Why this happen? Both two are the different compound containing the same functional group undergoes a similar kind of the reaction, but the rate of reaction is not the same. Rate of reactions are different. Why? And let us why this one happen, because here what is happening there, in a second case, in 2-butene there are the two methyl groups are there, and both the methyl group are the electron donating group, and already that carbon carbon double bond is electron rich, means nucleophilic in nature, and again they are giving electron, it become richer and richer, and therefore the reactivity toward the attack on that hydrogen atom, and we are getting as a formation of the 2-bromobutane is in a short period of time, and therefore this reactivity is there. Because from that what I am trying to explain, let me give another example. Let us see as there are, suppose another two examples. Let me clean the board first. Now third example, and there is a fourth example. Third example, let us see here. Here is a NO2, and here I am taking, both are the benzene, but two are different compound, and when that nitrobenzene, that is Br2 at room temperature, the resulting product form will be this one, NO2, and here is a Br. Now I am adding here 3Br2 at room temperature. We are going to get the product will be this one, OH, then Br here, Br and Br, right? Now Br. Now the name of this compound, most of you might be knowing the name of this compound is a nitrobenzene. The name of this compound is a nitrobenzene. What will be the name of this compound? We can call it as a meta-bromo-nitrobenzene, or you can call it as a 3-bromobenzene, because this benzene present at third position. Main functional group is a nitro. If you consider here, you are going to get 3-bromo-nitrobenzene, or you can call it as a meta-bromo-nitrobenzene. But this type of the polysubstituted, this is a disubstituted benzene, so we can call it a 3-bromo-nitrobenzene or meta-bromo-nitrobenzene, but it is a polysubstituted aromatic compound. Number should be starting from main functional group. Main functional group present in this structure is hydroxy. So start from here. You can move clockwise manner or anti-clockwise manner, it doesn't matter. 1, 2, 3, 4, 5 and 6. Now look at the position of bromo group. Here the name of this compound is a 2, 4, 6, means at 2 position, 4 position and 6 position there are the bromine atom. How many they are total? They are the 3, and that's why we can call it as a tribromophenol. So that is a IUPAC name of that compound, and the name of this compound is a simply phenol, simple phenol, this one, right? Now, but if you determine after the determination of the rate, they found that it is a very slow reaction, and this takes place, this one is a very fast reaction. Again look at here, benzene ring, here also has a benzene ring, but the one group which is present on that benzene, that here this is a electron withdrawing group present there, and this one is a electron donating group present over there. When electron donating group means they are giving the electron to this benzene ring, and therefore the reactivity increases, and so reaction takes place. The rate of reaction is very high, but in this case the nitro group is withdrawing the electron from the benzene ring, and therefore the pi electron density decreases in this case, and we are getting very slow reaction as a 3-bromo nitrobenzene. Means here the reactivity of the molecule not only decided by the functional group alone, but also other part present on the molecule, and therefore the reactivity is depending upon the other part of the molecule, and there are the several factors which can affect the reactivity of the organic compound, which is known as structural effect. And structural effect means this is the electronic effects are there, and how the electrons are displacement takes place, and therefore that the different compound has a different reactivity. Because even though the functional group, we know that the changes are occur at the functional group, but the reactivity of the molecule not only decided by the functional group alone, but other part present on the present in the molecule, and that is called as a that are called as a structural effect. And there are mainly 6 structural effects we are going to study in the chapter. First one is called as the inductive effect. Second one, we know that the resonance effect. Third one is a hyperconjugative effect. Fourth one is a steric effect. Fifth one is a tautomerism, and sixth one is a hydrogen bonding. I think with this, let us stop today here. Remaining inductive effect, resonance effect, there are the other structural effect we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.